Welcome back to my YouTube channel. Today we're going to be looking at how to solve non-homogeneous differential equation. Now, basically, we're going to be considering two methods. We're going to be considering method of undetermined coefficients and method of variation of parameters. So now let's get down to now. Our basic form of non-homogeneous differential equation is basically this. Now remember, on our last video we talked about homogeneous differential equation in which our function of x here is equal to 0. So basically for non-homogeneous differential equation, the function of x will be given. So basically this is the general form for non-homogeneous differential equation. Now to solve method of undetermined coefficients, there are some factors we need to note. Now, basically, if the function of x given in the equation is a constant, which is k, we take their general forms. For example, the general form of a constant k is equal to c. Now, if a linear function which is kx is given, where k is a constant or a coefficient of x, the general form will be equal to cx plus d. Now, if it is a quadratic function which is kx squared, the general form will be the general form of a quadratic function which is cx squared plus dx plus e. Now, if you are given a function of x which is the trigonometric, which is sine x, k sine x or k cos x, the general form of trigonometry will be equal to c cos x plus d sine x. The same thing goes for exponential. General form of an exponential is c exponential kx. Now, if the exponential we are given, we solve our complementary function and we are having the same function of exponential, we are having the same exponential at the particular function. Like I said, we're going to be solving general solution of this particular function, and we are going to be having two types of function. We're going to be having the complementary function and the particular function. The complementary function, based on our last videos, where this function here is equal to 0, those are our complementary function. All the solutions we solve when solving homogeneous differential equation based on our last video, those are complementary functions. So we're going to be combining that complementary function and the particular solution we are going to be solving due to this function of x given here. So basically, if you are given if this e exponential kx is found in the complementary function, we take it to be we take the general form of this exponential to be cx exponential kx, if and only if this kx, e exponential kx, is found in the complementary function. So these are just what you need to know about solving undetermined coefficient. So let's take this particular example where the x squared y divided by the x squared minus 3 dy dx plus 2y is equals to x squared. So let's solve. Solving this, we find our complementary function. The first step is to find your complementary function. Now, basically, just like what we solved based on our last video, solving complementary function will make this equation to be equal to 0. So we have the square xy minus 3 dy dx plus 2y equals 0, right? So now, applying our operator d method, this can be written as d squared minus 3d plus 2 open bracket y equals 0, right? So factorizing this, we have 2d squared equals 2d minus 2d minus 2d, multiplying together will give me 2d squared, and adding this we have minus 3d. So we have d squared minus 2d minus d plus 2 equals 0. So we have d open bracket d minus 2 minus 1 d minus 2 equals 0. So basically d is equals to 1 or 2. So then I can say my complementary function is based on these are real and different roots, right? So for real and different roots, I said the solution, it will be equal to c1 exponential m1x plus c2 exponential m2x, where my m1 is equal to 1 and my m2 is equal to 2, right? So we have c1 exponential x plus c2 exponential 2x. So this is my complementary function. I call it CF. Let's call it CF. So now the second step is to find your particular function, which you are going to be making use of this external function they gave us here. So the second step is to find your complementary function. So I can call it second step, second step is to find your particular function. Find particular function such that the particular function plus the complementary function gives me my general solution. So to find my particular function, what do I need to do? Now I'm going to be considering this. Since I use this for complementary function, I'm going to considering the external function they gave me here as to solve my particular function. So to solve my particular function, like I said from the beginning of the video, I said if you are given a quadratic function, which is this, you are given k x squared to be a function, the general form of this will be equal to what? Cx squared plus dx plus e, right? Now why is this? Because this is the general form of a quadratic function, because here you are given basically a quadratic function. So expressing this to this, you're taking, like I said, to get your particular function, you must express the external function they give you based on their general form. If it's exponential kx, it will be c exponential kx. If it's sine x, it will be what? C cos x plus d sine x. So we are basically expressing it based on their general form. So expressing this x squared based on my general form is what I have. So now let's proceed. So we have y is equal to take y to equal to cx squared plus dx plus e, right? Then dy dx now will give me 2cx plus d, right? Then d square y dx square will give me what? 2c, right? Now these are the values. I'm going to substitute all these values into the equation given. So basically I have 2c minus 3 times dy dx, which is what? 2cx, right? 3 times 2cx plus d. I have 3 bracket 2cx plus d plus 2 bracket cx square plus dx plus e equals 2x, right? So now we expand the following equation. So we have 2c minus 6cx minus 3d plus 2cx squared plus 2dx plus 2e equals 0. So taking the one for x squared and grouping the one for x and the constants, we have 2cx squared minus 6cx plus 2dx plus 2c minus 3d plus 2e equals x squared. That taken. So now we compare coefficients, right? So this is 2c compared to 1, because x1 here is the coefficient of x squared. We are comparing the two coefficients. Let's say 2cx equals x squared, 2c is equals to 1, c is equals to 1 over 2, right? Comparing the coefficients for x, since there are no coefficient of x, we call it 0, right? So taking this, we have minus cx plus 2dx equals 0, right? Then we have minus 6c plus 12 plus 2d is equal to 0. Since c is 1 over 2, right? Minus c bracket 1 over 2 plus 2d equals 0, which gives me 2 into 1, 26 is 3. It is minus 3 plus 2d is equal to 0, which gives me 2d is equal to 3 and d is equal to 3 over 2. Now, comparing my constants, since there are no constants, we also assume it to be 0 also. Comparing my constant, this is 2c minus 3d plus 2e equals 0, right? This is 2 brackets. My c is what? 1 over 2 minus 3 times my d is what? 3 over 2 plus 2e equals 0. This will cancel this, which is 1 minus 9 over 2 plus 2e equals 0. This gives me 2 into 1, 1 is 2. 2 into 1 times 1, 9 plus 2e equals 0. This is minus 7 over 2 plus 2e equals 0. Giving 2e to be equal to 7 over 2 and giving e to be equal to 7 over 4. So now my particular function, which we took as our general form to be cx squared plus dx plus e will be equal to, my c is equal to 1 over 2x squared, my d is equal to 3 over 2x, and my c is equal to 7 over 4. So my general solution to the differential equation will be my complementary function plus my particular solution, or my particular function. Given my complementary function in the previous question to be c1x exponential x plus c2 exponential 2x plus, taking my particular function here will be equal to 1 over 2x squared plus 3 over 2x plus 7 over 4. So this is the solution to the given non-homogeneous differential equation.